You're listening to the Talking Air Filtration podcast, where you get to know the people that make air filtration possible and help us all breathe easier. Because clean air matters.
We'll get insights from air filtration professionals and learn how they became successful in their careers. Along the way, we will discuss best practices, guidelines, trends, and challenges in air filtration in a variety of applications. We hope HVAC, air filtration, and indoor air quality pros, including business development, engineering, building owners, and facilities management, will enjoy the insights our guests will bring to this podcast. NAFA continues to lead the way in air filtration education, and Kevin Delahunt's Designing Built HVAC Filtration Systems presentation offers insights into designing and maintaining HVAC filtration systems that go beyond just filter performance. He'll explore critical topics like reducing particulate load in occupied spaces, the importance of filter hardware, designing for extraordinary events, and post-installation verification. Let's dive in.
We're going to move into our first session here, Design Built HVAC Filtration Systems for Optimum Performance. I'm going to introduce Kevin Delahunt to the stage.
Glad they didn't have the mobile one. I was watching that guy, the last guy that was on yesterday, and I was waiting for him to do a face plant off of here, so it was getting a little scary. How many members of ASHRAE in the room, by a show of hands? Okay. And how many attend the AHR show on a regular basis? Oh, just about the same. We'll get more people. Okay. The reason I'm saying that is that I don't know if you all realize, and I never realized until 4 years ago when I was asked to give a talk at ASHRAE, that for about the past 15 years, NAFA has had the opportunity to talk at the AHR show. And I don't know how many people are aware of that we've been doing that for 15 years. Not very many people. To me, it's such a great opportunity, a great time to get our message out to a different group of people, not just the people that are in this room. So this presentation, they allowed me to do it. It's sort of a preamble to what I'm going to talk about coming up in February. So in the past, I've done it mostly on the guidelines, but this one's going to be some things that are near and dear to my heart, and I think a message that we have to get out. And the message to the room right now is that there's an opportunity going forward. If we have this ability every year to do it, what's the next message for 2026, 2027, 2028? And I don't know if we have a vehicle for people to express that, to say, hey, I'd like to talk about this or to do a presentation. So I think it's something that we need to take a look at. So this isn't necessarily for the people in this room. You got to think this is going to be for an audience, hopefully of designers, and hopefully maybe of engineers, and hopefully of industry people, HVAC industry people. So the agenda is getting people back into healthy buildings, IAQ as a competitive advantage, why MERV 13, system efficiency, not just filter efficiency, HVAC filter design and maintenance, and facility flexibility and design. So the pandemic effect, one of the biggest things facing the facility managing industry is the vacancy rate in a building. Like if we think before COVID, buildings were mostly full. Commercial buildings were virtually 100% occupied. By the summer of 2020, it got down to 9%. And I think we look at today, most buildings in North America are probably at 50%. And I know in the city that we live in, many buildings were repurposed from a commercial office building to hotels and condominiums and that type of thing. So the industry has changed. And I think as our industry, it's really important. We want to get people back into a building. And again, very important to get people back. But the people coming back into the building I think they're much more educated than they were prior to COVID or the pandemic. They're coming in and they're asking very serious questions like, what am I breathing? Am I safe? And how do I know? What's in the air? And the facilities they're able to effectively display the quality of the air in the building, I think have a unique competitive advantage. And I don't think it gets expressed enough in the industry that indoor air quality is a competitive advantage versus another facility. Especially if you're trying to track a tenant, it should be a real bonus to have quality air and to be able to prove that on a regular basis. So Honeywell's Healthy Building Survey, some of you might have seen this in 2023, very high percentages of the people coming into a facility are asking those tough questions again. What am I breathing? Is it healthy? And how do I know? In some cases, like, people will not want to go into a building or work in a building where they perceive that the air quality is not of a standard that they expect. Strategies for improving indoor air quality, we're very aware of this: increased ventilation, increased filter efficiency, and supplement it with room air purifiers. Why MERV 13? How did we get to MERV 13? Why is it the buzzword during the pandemic? And again, the Epidemic Task Force done by ASHRAE, I thought it was a great, what am I thinking here? Just a document that they were able to put out very, very quickly. And, to go from MERV 8 to MERV 13 was, in my opinion, was a quantum leap in filtration. So, again, there's a downside to that. In some cases, we don't physically have the room, or the units are not capable electrically or mechanically to be able to pull air through a system. This is a slide I use a lot in my presentations. Again, why MERV 13? Well, it's a particle. It is airborne and will behave like other particles in that size range will behave. MERV performance versus virus on virus-sized particles. Now, some of the conversations that I heard lately, like, people are saying, well, I'm going to go back to MERV 8 because the pandemic's over. I don't need MERV 13. I think if you look at this and we talk more about what's penetrating a filter versus what we collect, or the efficiency of that filter, this makes a lot more sense. If you're looking at that chart, the bar chart, like, which filter would you rather have? Do you want a MERV 8 where the penetration is virtually 90-some% versus a MERV 13 where the penetration is a heck of a lot more? And if we talk about penetration, a MERV 13 is about 5 times or 500% better at removing that size particle than a MERV 8. It's much more impactful to say that versus this is 80% and that's 40%. Upgrading your filter system, it offers immediate result. If I take a MERV 8 filter out and put a MERV 13 filter in, as soon as that air goes through that product, obviously it's going to provide a much higher filter performance. And the second part of that is improving the filter integrity, the system, the hardware. Why MERV 13? MERV 8, 80% capture. So 80% of the particulate, especially in that virus size, particle size, is getting through the filter, versus a 13 where you get down to 750,000. This is a dramatic or drastic improvement over that the MERV 8 filter. And again, you go to MERV 15, MERV 16, or HEPA filter, sorry. Again, just small increment improvements, but a lot better. A 2-stage system, have a MERV 8 and a MERV 13 filter, acts more like a MERV 14 filter system as long as all the air is going through the filter. And again, ASHRAE standard 241, control of infectious aerosols, they're recommending a MERV 13. I can't see us going back to MERV 8. Like, tell me if I'm wrong, but I just don't see it. To me, it makes sense. Everything's pushing towards MERV 13. But this is where I'm going with this. We need to design this. We need to be involved in the design and the engineering of these systems. So the pandemic has emphasized 2 issues that could easily be addressed. And one of the biggest one is the hardware. Filter hardware has not kept pace with the advancements in filter technology. Micropore filters, if you think back to the last 15 years, have changed and evolved. They're much better than they were 15 years ago. But the filter hardware, from what I see, and again, I'm not in the field every day, but I don't see the filter hardware changing to support the quality of the filter that's in an air handling system. And the second thing that really bugs me, and it's bugged me since I started in the industry, is the lack of physical space in a unit. If I go to a unit and I want to upgrade to a better filter, usually I have 2 inches, if I'm lucky, maybe sometimes 1 inch, to actually provide a better quality filter. We don't have very many options in that size range. That's a real issue in our industry. The day of the built-up systems, using airflow and the gasket is to provide a better seal, I don't see as many of these anymore. Even large buildings that are being built, they tend to go with the package units and mini package units. And I can see why they do it. They can control the air quality, or not even the air quality, but the ventilation in a lot more zones than using just one large built-up system. And don't get me to talk about side axis tracking. I just don't get it. And I was talking with Ed the other night about this. We talked about, why is a HEPA housing 3.5, 4 times the cost of one filter, where I could put a MERV 15 or 16 in a 1 inch or 2 inch side axis tracking? That's maybe 1/100th the cost of the filter. There's a disconnect there, but also an opportunity in our industry to provide better hardware for the filter that is going into those air handling systems. And they're being punched out like crazy. I don't know how many systems are being sold these days compared to a built-up system. And again, I'm not in the field, but someone might say, no, we see a lot of built-up systems, but are we or are we not? I don't think so. Bypass. I mean, we've talked about bypass in years gone past, and everybody's got all these pictures, but visually, they tell a tale. Like you can see that 2 filters smushed together, and the dirt path and the airflow on the door itself, filters not coming to the door. We could change that during design. Like again, I asked the question, like, they know going in the size of the coil and how much air they want to put through a system. Could you not think that we could design it so the filters would come right to the door, like actually fill the whole space? This is not a real engineer dilemma. It shouldn't be that hard, but it is. It seems to be very hard to do. Again, filters put in, like a MERV 15 filter, MERV 16 filter in a 1 inch track fell out. What's the quality of the air in that space? What's the MERV of that filter system? It's probably 8 or 9. So I spend $150 for a module that's actually acting like a, I don't know, $7 or $8 filter. Yeah, this one I love. So whoever put the unit together realized, oh man, I got about 20 inches I got to cover. So I'm going to put that's a piece of metal on the door. So when you close the door, it actually fits in and to provide a spacer. And you can see below that, it's actually missing that one. So whoever was working on it probably banged his head about 3 times and then kicked it off. Like that's an engineered system. Like, really? Is that the best we can do as an industry? It just drives me nuts. Here's one here, so the bags are in sideways. The gaskets are falling off. The tracking's really dirty. The spacer was stuffed in the tracking. You always see that, like either it's on top of the unit, like take the spacer out, you put it on, forgot to do it, or you put it in the tracking. The filters don't come to the door. There's always 2 or 3 inches. That's why you see the dirt path on the door. But it has a great door gasket. So hope there's no engineer or designers. And again, That technology is out there. It's been out there as long as I've been in the industry. Bolt action, crank lock, like the HEPA design hardware, we should be able to put into a side access housing. And again, I think it's a great opportunity for anybody in the, where's Brandon, in metal or Ed in the hardware side of it. We need better hardware. Doesn't matter how good the filter is, if the hardware is no good, the system's not going to work.
Are your air filtration personnel NAFA certified? Ask if they belong to NAFA and have their certified air filter specialist or NAFA certified technician designations. The CAFS and NCT designations are earned after rigorous exams and demonstrate that the air filtration professional has a high degree of knowledge and professionalism. To learn more about NAFA certifications, visit nafahq.org.
There is better stuff out there. And again, another opportunity, just sealing the bank, like making sure the product is, all the air is going through the filter. Caulking, tape, very inexpensive, but a little onerous to do, but it needs to get done if you want the system to act like, or at least provide the efficiency of that the filter is. So, duct tape. This is a furnace. Again, either the door was fell off or is no longer there, but you can seal it into place. As our founder said, and many of you know or knew Daryl Sutton, but if it doesn't fit, it doesn't filter. The air, 100% of the air needs to go through the filter. This is Jeff Siegelt's, work on bypass and just showing, how a product can drop in efficiency really quick just by a minimum of bypass. We need to do system hardware audits. We need to go into system to make sure that the filter's performing the way that we expect and getting the performance that you want. And I'm sure everybody in this room should have a checklist of things they need to do when they go into a system. The bottom line is the goal of every filtration system needs to be system performance. We need to talk about system performance, not just filter performance. It's not just the filter, MERV 13, it's got to be the whole system. And that's the hardware and the filter itself. I want you to think about this. There's 130,000 K-12 schools in North America. Where's David? We were talking about that at our guideline meeting. And the average age of these the schools is about 50 years. In each system, so in each school, there's about 10 HVAC systems, which makes 1,300,000 systems, HVAC systems. The average age of those systems is about, 50 years. The U.S. government suggests that 41% of these units need to be replaced or retrofitted right now. Now just think about that number, and that's just one area of our business. So 533,000 pieces of HVAC equipment needs to be replaced or retrofitted right now, immediately. Now you can start thinking commercial buildings and hospitals and that. There's a lot of industries that are the same, but I'm picking on schools because if anyone's been on a school or rooftop units, they're in pretty bad shape. But great opportunity, and it's a good opportunity to move forward and to make sure that the units are actually supplied with the right filter, but also the hardware to support that. And that's not easy to get done. And what really worries me is that all we're going to do is just replace the existing piece of HVAC equipment with some shiny new one that really is not going to do what we would like it to do. Flexibility in design. This is pretty typical. When they talked about lack of space, you get up to a unit, guy says, yeah, I want to put a HEPA filter in my unit, and you go up there, and you couldn't get the filter out without a pry bar to start with. Where would you put the HEPA filter in? Where do you put a MERV 15 or 16 filter in there? Why can't we see units that actually have some physical space? How much extra does it cost to add a foot more to an air handling unit that, at design? I don't think it's very much. It might be 2 or 3%, maybe 4%. You might never use it, but it's at least there. Extraordinary event mode. Add a little more space. Be great to have. Pandemic mode. Wildfire smoke. Again, we were talking about it at the guideline meeting today. So I have some numbers here that I wanted to, in 2023, 15 million hectares in Canada were burnt. 15 million. Everyone know what a hectare is? It's almost 60,000 square miles of forest and ground were burnt. So that was our contribution to North America, Canadian wildfire smoke. So I'm not going to say you're welcome, but that's about the size of Illinois. Now put that in perspective. Just think about the vast size of that and the amount of particulate that were created in, 15 million hectares of land. What if we built a system and had, we're able to put in an upgraded filter during wildfire smoke season or a pandemic season where we could just slide in a 4 or 6 inch in MERV 15 or 16 filter? What if we needed gas phase filtration and that we had the capabilities in the unit to be able to do that? What the heck, even have 2 stages of it? Be pretty cool, wouldn't it? So in ASHRAE standard, I think 241, the infectious rate risk management mode, I don't know how that's out there. They're saying you need to do it. What does it look like for us? What does it look like for an air handling system? The only way I could see is that you actually have the physical space in there and the capabilities to add modules as required. If it's wildfire smoke, you want something to remove particulate and maybe some gas phase. We can't do it in the existing systems that I can see. The only way to do it is the next designs, they need to have that available space, the extra space to be able to do that. And the last thing I want to talk about is real-time IAQ data. And this has come up in a couple of talks, but this is in our building in Calgary, and it's, I don't know, Class C, Class D building, Sharon, like it's a dump, like really. But the air quality in the space is pretty darn good. I know a filter guy. And I know from years of like doing air quality analysis in Class A spaces and commercial buildings, the air quality is really good, like really good. And I also know that most of those buildings have been collecting data for 20 and 30 years, but they don't share it with anybody. I don't know if it's a liability issue or whatever, but they keep it to themselves. I'd like to be able to, you walk into our crappy little building in southeast Calgary, you can see exactly what the air quality is in that physical space real time compared to outdoor air, which I think is really, really cool. But I can walk into a $1 billion commercial building and there's no expression, there's no transparency. Why not? I think there should be. And to me, if you do that, I think the companies that will do it will have a competitive advantage. They'll be showing, here's our quality of our air. Why wouldn't you want to rent space from me? So filter replacement. Again, I want to talk about, we should, anybody that's changing a filter should have NCT training. They should understand what they're taking out of the unit and the possibility that those filters are contaminated, right, Tom? Yeah. So a good place to start there. So train your staff, the industry needs to get trained too, the people in the field, the HVAC techs, They should have a better understanding of what they're doing when they're changing filters. So takeaways are reach out to your filter supplier as a second set of eyes and ears to evaluate your air filtration system. Go through, do that audit in your system, know what's going on, educate your staff, monitor your air, especially for particulate, and increase outside air based on CO2. I've read probably, 500 or 1,000 papers in the last 10 years on indoor air quality. The statement on the left comes up every time. We spend 90% of our time indoors. And when I first heard that about 15 years ago, I'd think, yeah, you sleep. Yeah, it's probably about 90%. What we really need to talk about, though, is 90% of the air you breathe is processed. It's gone through a system. It's either been heated, cooled, humidified, ventilated, whatever. And when you put it in, in that context, you start thinking, well, then the question becomes, how well would you like your air processed? Would you like fries with that or whatever? It gets you start to think a little bit more about what you're breathing. I should have prefaced this by, again, this is for ASHRAE. I'm looking for comments and any pictures that people have and anything I can add to this. It's a work in progress, and I'm going to be delivering in February. So if you have any questions or comments or additions, I'm definitely open to that. So
You should
I
add
told you I had a good comment on
Yeah, I
the
know. I
fire.
was really excited to hear this today, but I think you should include the resource of airnow.gov. Anybody in this room heard of that, airnow.gov, and gone and used that?
Does that give you an air quality
It's
index?
the air
or-
quality right now, every day.
Yeah, outdoors.
And it's got sensors all over the country tracking ozone and PM 2.5.
Yeah.
You put that in front of yourself every day, you'll upgrade the filtration in your own home. And it's just the biggest problem we have is we're talking about something people can't see. Give them a way to see it every day. It's just right there, and it's got history too. You can go back in time and track it. It's not just for wildfires, it's for every day. So if you haven't seen it, go take a look at it.
Thanks. Yeah. No, good point. And as I was saying to Johnny, I like to cycle a lot, so there's a lot of days, especially during the wildfire smoke, I was looking at the air quality index and deciding, do I wear a mask today or just I stay indoors today or go have a drink? One of those. So, like I say, any comments you have, that's my details should be up there, not hard to find. And do you think that's a pretty good message to get to the ASHRAE group or the people that might go to that? And is there anything I can add? And I know Marissa will be doing it in Spanish, which is fantastic. Last year we had about 120 people show up for the talk we had, which was just great. But we'd like to promote it more, get more people out there. So thank you, everybody.
Thanks for listening to the Talking Air Filtration Podcast, a production of the National Air Filtration Association. Clean air matters.